With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, our question is given as friction is absent everywhere. Here, the threads, springs and pulleys are massless. Okay, so there is no friction and there is the threads and springs and pulley are considered to be massless. If MA equal to MB equal to capital M, then the angular frequency of the system for small oscillations will be here. 4 options are given regarding the value of angular frequencies. Okay, so we can check what are values given. So 4 values are given regarding the angular frequency. Okay, so first of all we can analyze what is given in the figure. We can write the force diagrams. So here a mass B is attached here, so there will be a downward force mg here. Here 2 pulleys are there, so there will be an upward tension 2T will be here. Okay, and there is this is a spring, and the spring force is given by K into X, plus here there is another body, its mass is also M, and it is downward force is mg. So we can resolve the component. Okay, on resolving the component here, we get the component along the spring is given by mg sine theta. So this is mg sine theta. Also another string is there, so tension is on the opposite direction. This is the force direction of the force on this figure. So at equilibrium, what happens? At equilibrium, all the forces we can equate. So at equilibrium, we get the equation as T is equal to K into, let this initial distance be x naught. So K x naught plus mg sine theta, and let it be equation number 1. Also 2T equal to mg, equation number 2. And equating 1 and 2, we get K x naught plus mg sine theta is equal to mg divided by 2. Let it be equation number 3. Okay, so from the force equation, we get the equation 1, 2 and 3. Next we can look the conservation of energy. Since when the pulley starts to move, what happens is that is when we compress the spring. So when we compress the spring, what happens is that compress the spring towards this direction, compress up to a distance x. What happens? There is a restoring force exerts on the spring, and due to this restoring force, this pulley will move. So the potential energy of the pulley is converted into kinetic energy. So then we can write the conservation of energy equation. So by conservation of energy, we can write the total energy E is equal to, first of all, the energy of the spring. Initial distance is x0 and we compress to x. So the potential energy of the spring is half x plus x0 into whole square, plus the kinetic energy of that mass A, it is half mv square, plus what is this? If we compress the spring to x distance, this mass will move upward by a distance x by 2 with a velocity v by 2, half of that object. Okay, then we get the kinetic energy of that mass is given by half mv by 2 whole square, and its potential energy, since it is upward, it is minus mg into x by 2. Also there is a potential energy for that spring, it is mg, what is that value? mgx sine theta. So this is a total energy term. We can solve by using the energy method. For energy method, we should take dE by dt is equal to 0. So differentiating this equation, we get LHS equal to 0, and we can differentiate each term. So when we differentiate half into k into 2 into x plus x0 into dx by dt. Okay, we differentiated that x plus next term 1 by 2 m into v can be 2 v square into differentiated into 2v into dy by dv by dt plus 1 by 2 m into here into 4. So 1 by 2 into 4 m into 2v into dv by dt. Here also minus mg by 2. Okay, mg by 2 into dx by dt, and the last term becomes plus mg sine theta dx by dt. Okay, this is after the differentiation, and we are familiar with the value dx by dt. We are familiar with this value, that is dx by dt is a velocity. Dx by dt is velocity and dv by dt is acceleration. So this equation becomes 0 is equal to, we can cancel 2, here 2 and 2 get cancelled, here 2 and 2 gets cancelled, and we get k into x plus x0 into v plus mva plus mva divided by 4 minus mg by 2 into v plus mg sine theta into v. So the equation can be reduced into this form. Then we can open the bracket. So 0 is equal to kx into v plus kx0. I am taking this v and this v as common. So kx0 plus mg sine theta into v plus 5 by 4 mva minus mg by 2 into v. What is kx0 plus mg sine theta? It is mg by 2. So this value is mg by 2. Here plus mg by 2 and minus mg by 2 into v. So we can cancel this two terms. Okay, then we get into v plus 5 by 4 m into va. V can be cancelled, or we get minus kx equal to 5 by 4 ma, or a equal to, a equal to 4k divided by 5m into x. Here there is a negative sign and there is an x. So this is the equation for the acceleration we obtain. Okay, in our question it is mentioned about small oscillation, and for small oscillation we are familiar with the equation for the acceleration. Acceleration equal to minus omega square x. So equating these two equations, we get omega square equal to 4k divided by 5m, or omega equal to root of 4k divided by 5m. So this is an equation for angular frequency, root of 4k divided by 5m. So what is the answer? 4k divided by 5m. See, option B is the correct answer. 4k divided by 5m. Okay.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.